Okay. So if you look over there on the board, okay, the I can statements did not change because we're basically going to be doing the same thing, okay? We should still, again, our goal for ourselves, you want to be able to say, I can identify rational and irrational numbers. We did some practice of that in the warm-up today. And then number two, you want to be able to say, I can solve equations using properties of algebra. Okay, so we're going to continue with equations today, but we're going to look at some more, well, just a little equations that have a few more steps now, okay? You guys seem to do pretty well with those single-step and two-step equations, but now we're going to kick it up a notch, okay, and do some of these more complicated kind of problems, okay? So we call this notes again, if you like, and we'll say, equations with like terms, okay, and variables on both sides. Okay. Equations with like terms and variables on both sides. Okay. So let's first of all talk about this idea of like terms. Okay, like terms. What kind of terms are like terms? Alex, you got an idea?
Like you have 1K and 2K, they are like terms.
Okay, so what makes them like?
They have the same variable.
Same variable. Okay, so like terms must have the same variables. Okay, we could also put in parentheses, because what about like, and I know this is a very basic thing, you maybe just weren't even thinking about it, but what about like 2 and 3? Are 2 and 3 like terms? They don't have any variables though, right? But they're both like, because they're both just numbers, right? So we can say same variables or no variables. Sometimes it's just numbers, right? Okay? Is that enough to have like terms if they're just the same variable? What do you think? I'll give you an example here. I'm going to put it up on the board. Okay? We'll use the k's again. There's k, there's k, but that's a k squared. Are k and k squared, are they like terms? They're not, right? What's different? What makes these different? Same variables. What's different about them, though? There, yeah.
1 squared.
1 squared. So remember what this is called? An exponent. That's right. So they have to have the same exponents as well. Now, for our purposes, okay, because things start getting really complicated when you throw in exponents like powers and stuff. Okay, we will not be worrying about like squaring stuff right now. Okay, we'll worry about that later. For right now, we're just going to stick to, like Alex was pointing out earlier, just like K's, N's, A's, B's, C's, D's, X's, numbers. Okay, those kind of things. Nothing with variables. All right, so let's take a look here at an example of an equation we're going to solve. So our directions here are going to be solve the equations, okay, for the variable. Solve the equations for the variable. First example here. Okay, 5x plus 3 minus 2x equals 11. Just like that. Okay. So, when we run across a problem like this, there are many possible first steps that we could take. And there are some that are better than others. So I don't want to make you guys fit too much of a mold here, but I'm going to make a suggestion as a person that cares about you being successful on these. All right, I recommend that if you see like terms, that you combine those like terms on the same side first. Okay? So Alex, yes, you want to point something out?
I did 5 plus -2.
Okay, right. So on the same side here, we have like terms, 5x and minus 2x. So combine like terms first. Okay, combine like terms first. Okay, on each side. So on the left side here, we have like terms of 5x minus 2x. What does that make, Alex, when we combine them together? 3x, okay? So 5x and the minus 2x, they're on the same side, so they just combine together, okay? We're not, notice I'm not doing like, I don't put like a plus 2x underneath and put a plus 2x over here, because it's on the same side, I just put them together, okay? Just put them together. So 5x minus 2x, 3x plus 3 equals 11. Okay? You only do the opposite stuff when you're trying to do the same thing to both sides, not on the same side. Okay? You do the same side stuff, you just combine it together. All right? Let's see here. Mark, are there any other like terms here for us to combine? No. No. Okay. On this side, we have 3x and 3. They're not like. On this side, we just have the 11. So no, you're right. So Mark, can you tell us what would be the next step then at this point?
Subtract 3
Yeah.
3 and 11.
Subtract 3 from both sides. You got it. So now we'll just solve. Okay, so we get 3x equals 11 minus 3 is 8. And then last step, Mark, please take it away.
Divide 3 over 8 by 3.
Yeah, divide both sides by 3. You got it. Well done. X equals 8 over 3. Okay, there's our final answer. Just like that. All right, questions on any of that?
Can you simplify it?
Can you simplify it? If you want to, how would you like to simplify it?
I don't know. I got a different answer. I got 2.5.
2.5?
Yeah.
Well, we can check your answer. Let's do that. So if we do 2.5 times, or let me do this, 5 parentheses 2.5, so I'll plug the 2.5 in for the x there, plus 3 minus 2 times parentheses 2.5, I get 10.5, not quite 11. So it looks like maybe you made a misstep there somewhere. Did you, let's see here, did you subtract 3 from both sides and get 8?
No, I got 7.
Ah, there it is. There it is. Okay. All right. There's that one. Let's try another one. Let's try another one here. Okay. How about 12.7 equals 4 minus 3x minus 1.5 plus 2x. Okay. So there's that. Right. Okay. Erica, do you see any like terms here for us to combine? Okay, so on this side, right, it's just the 12.7, so there's nothing to combine there.
Yeah.
But looking over here, do we have any like terms? Okay, so the 4, that's a number. What's another number that we have there? 2 is a number, but it's got the x next to it.
1.5.
Yeah, the 1.5. So we can combine the 4 and the minus 1.5 there. Okay, that's going to give us 2.5. Okay. Erica, what about that minus 3x? Does that combine with anything? Is there a like term to that? Yes, very good. So it's negative 3 plus 2. So negative 3 plus 2 is negative 1. So minus 1x, like that. Okay, so those also were like terms. Okay. I like to also, if you can see here, I like to underline like terms. I think that helps when I combine them. And you'll notice I did a single underline for the numbers and then a double underline for the x's. You can use whatever you want there, but I just like to show them because they group together that way. Okay, so good job, Erica. Well done. All right, let's go to somebody else here. All right, how about Caden? What do you say about from this point, Caden? How can we continue from here? What should be our next step?
Subtract 2.5 from both sides.
You got it. Subtract 2.5 from both sides. So we're left with, what's it going to be, 10.2, I think, equals negative 1x. Okay, you got it. And then, Catherine, you want to finish it off for us here? What's our final step right here?
Divided by 10.2. Divided by negative 1.
There you go. Divide by negative 1. You got it. Get that x by itself. X equals then negative 10.2. Okay, just like that. Okay. Any questions on any of that? Are you ready to try one on your own? Maybe? Maybe not? I'll take your silence as a yes. Here we go. Okay, I'm going to have you guys try here. Try one. Okay, so again, combine like terms. All right, and then solve. Okay, we'll do... Oops, I'm off the screen. There we go. 1/2 x minus 3 plus 1/4 x equals 7. Okay, you may use your calculators if you like. Okay, if you don't have a calculator, well, make sure you get a hold of one here. I have some I can borrow too. If you're not comfortable with fractions, that's okay too. Maybe. Let me see. I've got a few I can let some folks borrow. I've got 3 calculators that I can lend out to folks if they want to borrow one. So would someone like one to borrow? Okay. Okay, one here and one there. But you can use your phone there to do it. Okay. It won't be too bad, I promise. It won't be too bad. If you want to try and use your phone, if you don't have your graphing calculator with you today, you can use your phone, okay? But please do get your phone, get your graphing calculators. Okay, get those handy. But you can use your phone's calculator if you'd like to for this one. Okay, question? How do you divide? So what are you trying to do? Show me what you're trying to do here. Okay. So be careful here. It's a minus 3. So to undo minus 3, should you divide by? What should it be?
It should be add, but how
Yes.
do I...
How would you still divide though?
Yeah.
Okay. So yeah. So once you add, it's gonna be 10. Actually, we'll just go ahead and make that 10. We'll just go ahead and do there. There we go. So then we have 3/4 times x. So now you would want to divide by 3/4, right? So you're gonna type in 10, right? And we hit the division sign. And then we're gonna divide by 3/4. Since it's a fraction, I'm gonna put parentheses around that fraction. Like that. There it is. You can hit math enter if you want to. Make it 40/3, or you can just do 13.3 with a line over the top of your choice. That's it. Ben?
Alright, not bad, yes.
Oh. So your work's looking good there. So you got, so if you multiply both sides by 4 there, you should have gotten 3x equals 40. Right, because there's still a 3x.
Yeah.
And so you would want to do 40 divided by 3. Yes. Oh, it doesn't turn on? Womp womp. 94.6. Bad one. This calculator is a little wonky because here's refurbished. Okay. So if you want to use your phone, do you have your phone? Or do you want to use that? Same. No? So, what are your like terms? So you add those up. Right? And Yeah, that's fine. 1.5 x.
Yeah, I divided it by 15.
Okay, be careful.
And then I divided it by 10.
So you're right. This was right.
Yeah.
Haven't we been doing answers with like decimals and stuff then, right?
Yeah, but I'm just confused on how that would look like the answer. To make my guess would be a real problem.
Oh, I see what you're saying. Well, I mean, if you think about it, right, we're subtracting 3 from a quantity, and then we're doing 1/2 times something and 1/4 times something. So that's going to need to be a big number, because when you multiply 1/2 times something, it gets smaller. So we need that x to be something kind of big, so that way when you have it, it gets to something like 7. So does that make a little more sense? I mean, yeah, it should be a bigger number. I see. I like how you're thinking. I like that you're thinking, and whatever makes sense. That is tough. Remember, you can always check it by putting it back. It should be. So let's. So you need to add 3 to both sides, right? -3, so you only cancel by adding 3 to both sides. So 10 thirds, yeah. Or 40 thirds, I mean, that's right. Yes. So yours is reversed. Make sure you put parentheses around it. Yeah, because you might have mistyped that. You have it written correctly, but then you just yeah, it's 12 digits. Wait, trying to get out of here, Alex?
Yeah.
Try not to be in here for longer than you need to.
Yes.
You cut me deep, Alex. You cut me deep. Just kidding. All right. Question? On the calculator? All right, I'll come right back. All right, we're going to go over this problem here, guys, in just 2 seconds. 1, 2. Say again, sir. Okay, let's go over this problem here. We still have a few more things to look at, all right, after this one, but I want to make sure we got this one done. Mr. Witt was real mean, throwing fractions at you, okay? But some of you guys still got it okay, which is good, okay? So let's go to some folks here. Hannah, can you help us out? Do we have any pass? Okay, you didn't even let me ask the question, though. Hannah, are there any like terms in this problem?
Yes.
Okay, what are the like terms?
1/2 x and 1/4 x.
All right, see, that you knew more than you thought I was going to ask, right? Okay, so we got to combine them. And that's where you maybe feel uncomfortable, yeah? All right, so do you know how to type fractions in your calculator? Parentheses, 1/2, right? Plus, parentheses, 1/4. I'm doing plus because it's a positive 1/4 there. Okay, hit enter. Math, enter if you like. 3/4. You can use the 0.75 or the 3/4. Your choice. Which do you prefer, Hannah?
3/4.
3/4. Ooh, she wants to keep it as fractions. All right. We still have the -3. We still have the 7. All right, Hannah, you're off the hook, though. I'm going to go to somebody else. All right, let's go to JP. JP?
All right, so after at the step.
Wait, first of all, sorry. Are there any more like terms?
No.
No. Okay, go ahead. What's the next step?
You have to add 3.
Add 3 to both sides. Okay, you got it. Can you go ahead and finish it off for us?
And then don't you, is it times by 3 or multiply by 3 or divide to get rid of the fraction?
Right, so we have a couple options here. Option 1, we can get rid of the fraction all at once. We can treat it as one whole thing and just say this is 3/4 times x. So to undo times, we should what?
Divide.
Divide. So we can choose to divide both sides by the fraction 3/4. That'll exactly cancel that fraction. And then in our calculator, we will type in 10 divided by parentheses 3/4. Okay, just like that. Hit enter. We get that decimal. Math, enter, and we get a nice fraction there, 40/3. So that's one option. Okay. Okay, and that's our answer. The other option is if we had that 3/4 x equals 10, we could take the fraction apart piece by piece. So we could get rid of the divide by 4 by multiplying both sides by 4. That would cancel out with that, and we'd have the 3x still equals 40. Okay, and then we can get rid of the 3 by dividing both sides by 3. Okay. For those of you that don't want to be held down by your calculator, right, and always having to punch in buttons, this is the way to go without having to use a calculator. Okay, but if you like to use your calculator, feel free to do it that way too. Either way, really. Okay, but you both get the same answer. Okay, questions on that one? Are we feeling good on that? No questions on anything? Okay, Ms. Mulcahy, you're feeling good?
I'm looking at the 3/4 divided by 3/4 to get rid of the 3/4.
Mm-hmm.
Yeah, see, because I did it the other way. So I'm not used to that way. And that,
It works.
It's not really jiving with me.
That's
I'm
okay.
not really getting it.
Doesn't have to jive with you. If you're okay with this way, you're okay.
Okay, I'm not going to do it the other way.
Yeah.
I have my own way.
But if you want to take care of it all at once, you can. You can really divide a
How does
fraction by a
dividing a
fraction.
fraction by the fraction get rid of the fraction?
So, I mean, we're taking 3/4. We're taking a number, and we're dividing it by itself. Well, any other time you divide a number by itself, what do you get? You get 1, right? So let's put a 1.
Okay.
It exactly cancels out.
All right, I believe you.
Okay? There's another property of mathematics. I'll show this too. There's another property of math. When you divide by something, it's the same thing as multiplying by its reciprocal.
Yeah, well, that's
Okay.
what I started to do at first, and then that wasn't really working out for me.
Okay, right. So another way here, some people might look at this and say, 3/4 x equals 10. I can multiply by the reciprocal on both sides, and those will cancel, and then I get the 10 over the 1, 40 over 3. So that also works.
All right.
It works. You can multiply by the reciprocal.
Multiple ways to get the answer.
Right, and hopefully, one of you guys, will pick one of those and go with that. All right. That's that. Let's continue on here, though. So that's a nice way to do it too, if you liked using the reciprocals and stuff. Okay. I also said variables on both sides, though, didn't I? Okay. Do we have like terms here? Do we have like terms here?
No.
So I would kind of expect, I'm okay with kind of either answer here, because in a way, I'm not really sure. No. Why do you say no?
I'm guessing.
You're guessing? Okay. Well, let's talk about it individually. On the left-hand side of the equation, do we have like terms? Definitely not, right? That's got an x, that doesn't, not like. On the right-hand side of the equation, do we have like terms? Definitely not. Numbers, variable, no. Okay? But then if you consider the equation altogether, well, there's an x here, and there's an x here, but they're across the equal sign from each other. So now, we can't just put them together. I can't just do 1/3 x minus x, because they're across the equal sign. Instead, I have to move. I gotta move the x over to here, or move the 1/3 x over to here. Okay? Which one do we want to move? Pick one. 1/3 x or negative x? Oh, I heard the 1/3 first. We're gonna do it. Too slow, Miss Mulcahy. I'm sorry. Minus 1/3 x from both sides. Okay. So again, there's many steps you could do for your first step here, and they're not all wrong, okay? There are many steps that are okay to do here. But again, as someone that cares about you doing your best in these algebra equations, I'm going to suggest, okay, that you get the x or the variables together first. On one side. Okay? That's my suggestion to you first. First. Okay? We already checked for like terms, so that's really the very first step, but there are no like terms here to worry about. Now we're going to get the variables together. Okay, so the 1/3 x, take away 1/3 x, what happens to that?
It
Goes away. Okay? Still left over here, though, is a 2. Okay? The negative 7/3, that doesn't have anything to combine with, so I'm just going to bring that down. We have a minus x minus 1/3 x. What's the number that's really in front of this x right here?
1.
A 1, right. So it's really negative 1x minus 1/3. So in my calculator, I'll type in negative 1 minus 1/3. Okay, negative 1 minus 1/3. Hit enter. Okay, you get negative 1.33333 repeating, which is negative 4/3. So minus 4 over 3x, just like that. Well, now it should be easy. It's just like what we did yesterday. Just like what we did yesterday. Okay? So, Dylan, what do you say here? What should be our next step? Say pass? Okay. How about Matt T again?
You wanna minus the negative 7 over 3 for the 2?
From both sides? Okay, so if we want to cancel out negative 7/3, do we want to subtract 7/3? I think you said this. You said subtract 7/3 like this, right?
Oh, yeah.
So if we subtracted 7/3, negative 7/3 minus 7/3, that won't cancel. So instead we can add them, right? Negative 7/3 plus a positive 7/3, they will cancel now, right? And then 2 plus 7/3 is going to be, I could have done this in my head, oh well. Okay, 13 over 3. And that's negative 4/3 x. Okay. Dylan, how about now? What can we do now? Times 3 on both sides? Okay, so you want to get rid of that denominator first? You got it. We can do that. So those 3's will cancel. Those 3's are actually going to cancel too. We're left with 13 equals negative 4x. Last step. Divide by negative 4. You got it. Okay, so x equals negative 13 over 4. Okay, or if you like, you can say negative 3.25. Okay. All right. Let me give you guys one to try here. All right, so you guys try this one.
Really involved, Mr. Whitmire.
Why is that?
Because making my brain hurt.
Good.
Whatever.
Means it's growing.
True. That's true.
Okay, there's one for you guys to try. 2.5x minus 3 equals 1.2x plus 5.9. Okay, go ahead and solve that. seconds, and then we'll go over this one here. 30 more seconds, and then we'll go over this. I give them the freedom to do it the way they think is right. But I agree, I prefer the other way. But that's their preference too. They'll figure that out as they go, I think. Let's take a look here then. All right, time's up. Let's take a look. All right, so Sky, can you help us out here? Do we have any like terms on this side to combine?
No.
Nope. Do we have any like terms on this side? No. Okay, so what did you do for your first step?
I got rid of the 2.5x.
You got rid of the 2.5, so you subtract 2.5 for both sides?
Yeah.
Okay, we'll do that then. I know you're not the only one that did that. So that's canceled. What's still left over here? Very good, a negative 3 because there was a minus in front, so it becomes negative. 1.2 minus 2.5 is negative 1.3x plus 5.9. Okay? So now our next step here, right? And Sky, do you want to go ahead and what could we do for our next step then? You got it. We'll subtract 5.9 from both sides to start getting that x by itself now. So you got the negative 1.3x there. Negative 3 minus negative 5.9, or sorry, minus 5.9 is negative 8.9. Okay, and then last step. Go ahead, take it away, Sky. Pass. Okay. Let's go to, it's a nice softball here we got. Erica, what do you say? We got negative, well, let me maybe write this a little more clear for you. We have negative 8.9 equals negative 1.3 times x. From here, Erica, how should we finish it off? To get the x by itself. Divide both sides by what?
I want to say 1.3.
Yeah, the negative 1.3. There, you got it. That's right. We want to get that x by itself. Very good, very good. So negative 8.9 divided by negative 1.3 is 89/13 as a fraction there. Okay, so there it is. Questions on any of that? How many people? Who got 89/13? Yeah, good job, good job. Okay, if you didn't, that's okay. Remember, there's still partial credit and stuff like that. Anyway, your homework's in front of you. It's going to be the odds. The odds. So 1, 3, 5, 7, 9, 11. Oh, you need one, don't you? 1, 3, 5, 7, 9, 11, please. Okay.
Can I have one too, please?
Yes.
Practice as well.
Practice makes
Well,
perfect.
yes, indeed.
Okay. That's going to be your homework, so you can go ahead and get started on that.